Hi everyone, welcome back to the channel. In today's video, we are going to solve a very interesting problem from leetcode called minimum changes to make alternating binary string. We will walk through the idea step by step, understand the key observations that simplifies the problem, and then implement a clean and efficient C++ solution. So let's get started. We are given a binary string S consisting only of characters 0 and 1, and in one operation we can change any 0 to 1 or vice versa. The string is called alternating if no two adjacent characters are equal. So we are given a binary string. A binary string means the string contains only two characters, 0 and 1. Our task is to calculate the minimum number of changes needed to make this string alternating. Again, alternating string means two adjacent characters are the same. For example, if we have a string like 010101 and so on, this is an alternating string. Also, 10101001 and so on, this is also an alternating string. But something like 0011 or something like 1100, this is not alternating because we have repeated adjacent character. The only operation we are allowed to perform is changing a character. For example, we can change a 0 into 1 or change a 1 into a 0. And our goal is to perform the minimum number of such changes to transform the string into an alternating one. Now, here is the most important observation that simplifies this problem. For any string of length n, there are two possible alternating patterns. The first pattern starts with 0, like this one. Let's say we have string in here equal 8. So the first pattern starts with 0, like this one, and the second pattern starts with 1, like this one. So instead of trying many possibilities, we only need to check two scenarios. First one, how many changes are needed to convert our string into the first pattern that starts with 0? And the second scenario is how many changes are needed to convert our string into a pattern that starts with 1? And the final answer will simply be the minimum of those two values. Okay, let's walk through an example to understand the problem more and more. Suppose that the original string, we have a string like 0, 1, 0, 0. So the first pattern we need to compare with is the one that starts with 0, which 0, 1, 0, 1. So in this case, the first character match, the second match, the third one match, but the fourth one didn't match. So we will call it here that we have one mismatch. So for this pattern, we have one mismatch. Let's name it start with 0. Let's move to second scenario. The expected pattern that starts with 1, 1, 0, 1, 0. If we compare it with our original string, we will find that the first character didn't match, the second didn't match, the third didn't match, and only the fourth one matched. So here we'll call it that we have 3 mismatch. And finally, we take the minimum between the two patterns. So the answer will be 1. But before moving to the code, here comes a very nice optimization. If a character matches the first pattern, it will automatically mismatch the second pattern. And if it mismatches the first pattern, it will match the second pattern. So as you can see in this example, the first 3 character matches in the first pattern. So they mismatch in the second one. And also the fourth character in the first pattern mismatch. So that means it match in the second pattern. So the conclusion here is that the mismatches of the second pattern can be calculated easily using the first pattern, using this formula. Let's name it mismatch 1, means the mismatch of the second pattern that start with 1 will equal n, which is the length of the string, minus the mismatch of the first pattern, or the pattern that start with 0. So now we only need one loop through the string. So let's take a look at the code. First, I initialize a mismatch counter. We call it mismatch 0. So mismatch 0 equal 0. This will count how many characters are different if the pattern start with 0. And also, let's store the string length in a variable n. Next, we will loop through every index in the string. And for each position, we determine what character we expect. So for int I equals 0, int I equals 0, I less than n and plus plus I. Then we will determine what is the expected character. So let's name it expected. And to get the expected character for pattern that start with 0, we will use this modulus operation that determine if we are in an even position or an odd position. So if we are in an even position, like 0, 2, 4, 6, and so on and so forth, that means that we are expecting 0, else we are expecting 1. Then we need to compare the expected character with the actual character in the string. If they are different, we increment our mismatch. So I compare the current character in the string, and if it doesn't match our expected character, that means we have a mismatch here. We will increment our variable mismatch. After finishing the loop, we now know how many changes are required to match the pattern starting with 0. To compute the mismatches for the other pattern, we simply subtract this value from the string length. using the formula we have defined before. So let's say int mismatch 1 equal in minus mismatch 0. And this is, let's name it the opposite pattern stored with 1. I'm sorry, this has to be outside the loop. And finally, we return the minimum between the two mismatches for both patterns. Let's run it to make it error-free. Yes, all the test cases pass. Let's submit it. Here we go. So again, in terms of complexity, we scan the string only once, so the time complexity is O of n, where n is the length of the string. And we only use a few integer variables, so the space complexity is O of 1, which means constant extra space. And that's it. That's how we solve the problem in a clean and efficient way. If you enjoyed this explanation, don't forget to like the video and subscribe to the channel. And as always, keep coding, and I'll see you in next problem. Bye.